Okay, so a polynomial is an expression that consists of constants, variables, with whole number exponents and coefficients. So we cannot have division by a variable, and we will not have an infinite number of terms with a polynomial. It's a finite number of terms. So what I have are some examples of polynomials, like 2n plus 3 is a polynomial. The number 11 is a polynomial. 42a squared b to the fifth minus 6a, that's a polynomial. Okay, we classify polynomials in two ways. We classify them by number of terms and by degree. And most of you remember this, which is really cool. So if it just has one term, we call that a monomial. 2 terms, it's a binomial. 3 terms, it's classified as a trinomial. And if it has more than 3 terms, we just call it a polynomial. Because what does the prefix poly mean? One. More than one, many. Okay, I have examples of monomials, binomials, and trinomials. And when I was walking around, many of you were writing quality examples for yourself. That's awesome. You do not need to change yours. So any questions about how to classify a polynomial by the number of terms?
Easy.
Those of you that were in enrichment in elementary school, did some of that Caesar's English come back to be helpful at this point? Yes. Do you not remember that?
I was in
Your
enrichment.
prefixes and your suffixes and,
Like, I was in
and
enrichment.
your vocabulary? Alright.
I was one of those kids that was like, I took all the classes that the enrichment kids classes, but I wasn't in enrichment.
Alright. The next way to classify is by degree. How do you find the degree of a monomial? Okay? It is either the exponent or it's the sum of the exponents. So, here in example A, the degree of this is just the exponent, which is 2. But here we have multiples, so we add them and we get 5. This would be 7. Now, if we have a polynomial instead of a monomial, what you have to do is you have to find the term of highest degree. So in this example, 4x to the 4th is my term that has the highest degree. So the degree of this polynomial would be 4. Not the coefficient, it's the exponent. I really should have made that coefficient something different. Alright, and either Tori kept her notes or she knew this part from last year. She was spouting these off. So, if it has a degree of 0, that is a constant. Just a number. If it has a degree of 1, we call it linear. A degree of 2, quadratic. 3, cubic. 4, quartic. 5, quintic. After 5, we would just say the 6th degree, the 7th degree, the 8th degree, the nth degree, whatever the degree of the polynomial is. That's all I expect from you. And I made up my own examples. Some of you made up yours. You're welcome to keep yours. You do not need to change them to mine. Okay, so the third part of your homework is the classifying practice. That's the part that's below this. Okay? Now, you'll notice on my printout, it says Unit 7 at the top of the page, and at the bottom of the page it says Unit 2. Shame on me. I changed the top but not the bottom. This used to be Unit 2 last year, and now it is Unit 7. They merged Unit 2 and Unit 5 from last year to make Unit 7. Unit 5 makes 7.
This is basically just like a review.
Today is a review. Yes, ma'am.
But are we like building majorly like off of this?
Tiny bit, but not major. No, nothing major today. Okay, so in this example, it just gives you one that is higher than 5, and because this has a degree of 9, we would just call it a 9th degree. 9th degree binomial. Okay?
All right.
All right. All right, so this is part of your homework, and we have some workbook problems. So, if you'll open up that workbook to page 76, today we're going to also look at adding and subtracting polynomials.
So are we not going to be using our other workbooks?
That is a good question. We are done with geometry. So, if you would like to store your geometry workbook at home, that's fine. If you'd like to use it as part of a bonfire, that is fine. You can do whatever you like within reason and with permission from parents with the geometry workbook. Now, the geometry book, some of you did check out a book. Others chose not to. Those of you that did choose to take a geometry book, I need to collect those because this semester they'll go to the students that are in the first accelerated course.
You name all the people
I'll pull that out.
we should each like go over there and like hand them to like a student. And
Oh, pass it on.
pass it on.
No.
With like a note. Just,
Yeah.
Mayonnaise rated
Lucky you.
Gonna hand to him and say, have fun.
I'll give them a box of chocolates.
Yeah, I'm not sure if I.
Sound like you never know what you're gonna get. Yeah.
Okay, Caitlin, you did not take that.
Did I?
No. Caroline, you did not take the guide.
I think I took one.
You did. Blythe, you chose not to have one.
What about you, Tony?
Sam did not take one. Tony did not take one. Blake and Luke did not take one. Everybody else did.
Hi.
Yeah,
I did take one?
I didn't even do it.
Alright, I'll find it.
All right. So now that we're all on page 76 of our workbook, and we know to bring in those geometry books, today we're going to talk about some operations with polynomials also. So here we have number 1, and is this on page 76? Yes. Okay. So if we have these two expressions, and we're to add those, all we do is add like terms. So we look at our like terms, and we add them up. All right? So what is 2 plus negative 1? Okay, so that gives me 1x to the 4th. Okay? And then we look for other like terms. Oh, I see them. Negative 6x squared, positive 2x squared. What does that give me? Negative 4x squared. And then I look for more. Positive 8, negative 12 is minus 4. Now, this result is in standard form, and by standard form, I always go from highest degree to lowest degree. And that is the form in which we write our answers. We'll write them in standard form. So, this has how many terms? 3, so it would be classified as a trinomial. The degree of this trinomial is?
Quartic.
Very good. So we would call this a quartic trinomial.
Just rolls off the tongue.
Doesn't it? Okay. All right. Number 3. We would add like terms. Oh, there's 1/4 power. I'm going to start there. So my first term will be 7x to the 4th. Here's a third power. There's another third power. So that gives me 3x cubed. Okay, squared. Whoop, only 1. So this would be, was this a minus problem? Okay, good. Okay. And then this would be 5x squared plus 3x plus 16. So this is another quartic and is a quartic polynomial. Very good.
Do you have to write the names?
You do on that little half sheet, on the bottom part of the notes, but you don't have to. Okay, you try number 4.
time is this class out today? It's all weird.
It's on the board.
Oh.
We're at 2:52.
I've been confused all day.
Okay, what'd you get number 4 to simplify to?
5x
That is correct. And how would we classify that?
Quadratic.
A quadratic binomial. Any questions? All right, subtraction. What do we change subtraction to? Very good. So this becomes plus, this becomes positive, this becomes negative, this becomes positive. So we change subtraction to adding the opposite of everything that follows. The entire polynomial that follows the subtraction, we would change all the signs. And then it's just an addition problem. Okay, so what is the result of this one?
6x to the 4th minus 8x to the 2 plus 20, and it's a quartic trinomial.
I think it's 3. 3x to the
That's
4.
probably what I meant to say.
Yeah. Plus 20. And that is a
Yeah, I saw
quartic
4.
trinomial. Very good. Okay. I said you try and then gave you the answer. So if you tried it, did you get
Oh, yeah, we did.
Here, I'll hide it real quick. You try number 7 now. Okay, so you should get negative 7x cubed minus 5x squared plus 5x plus 1. Any questions about number 7? Alright. Okay, number 11 is not really difficult, it just does have words. It says, according to the data from the U.S. Census Bureau, the total number of people in the U.S. Labor force can be approximated by that function, where x represents the number of years since 1980, and t of x is the number of workers in millions. If the number of women in the U.S. labor force can be approximated by the function w of x, write a polynomial m of x that models the number of men. So what would we do to find the men if given the total and the women? So we would subtract them. Very good. So all you would have to do is take d of x and subtract from that w of x. And so we would get a function m with respect to x, which is 0.001x squared plus 0.74x plus 61.5. Okay, then if they ask us to estimate the number of men in the labor force in 2008, which is kind of funny because if it's 2008, would we really need to estimate? No, we should just be able to look up the data. But we'll pretend because this is, anyway. All right, so how many years after 1980 would be 2008? 28. So we do m of 28. So we would plug 28 into this function. And so we would get that 28 is approximately 83 million. You get 83, but this says in millions, so it would be 83 million. And that's what we get by plugging 28 into the function.
That's a lot of math.
pair analysis problem. And they were asked to find the difference here. The student work is shown here. So they worked it out and they gave spaces for things that were missing. Like there's no cubic here, so they left a space. And then they're subtracting. Now, when you subtract, what do you have to do with all these signs? They did. So they changed the first sign, but they didn't change the rest. So the student failed to completely distribute the negative through the second polynomial. Whoop, that's supposed to be the word through. Doesn't really look like it. And you know what? When my students miss subtraction problems, that's what happens. They just get going really fast sometimes and don't distribute the negative all the way through. Okay, the last thing we're going to talk about today is actually in part of the next section. It's multiplying through by monomial. And that's all we're going to do today. Tomorrow we will look at multiplying binomials, multiplying trinomials, expanding binomials, all that sort of thing. So let me just give you a couple examples for multiplying through by monomial. So we take one term and we're going to multiply through. And all that means is we distribute. So this is really nothing new. You've been distributing for a long time. So we can distribute here, and we get 3x plus 6. Okay, if we distribute here. Now, remember when we distribute a variable through, if we are multiplying like bases, that's going to change our exponents. What do we do?
So 2n squared
Very good. This
minus
would
8n.
minus 8n. So when you're multiplying like bases, you add the exponents. So when I distribute here to a squared times a to the third, when I multiply like bases, I add the exponents, it would become a to the fifth. Okay? Now, it was a negative times a positive, so it ended up being negative a to the fifth. Now, negative a squared times a negative becomes positive 4a what? To the third, cubed, good. And then what would my final term be?
Negative 2a squared.
Beautiful. Okay, so you try. Number 4. Okay, how'd you do? Alright, now with number 4, we don't really have the standard form like we would with a polynomial that's only in terms of a single variable. That's when standard form matters. So if it's all in terms of x, or if it's all in terms of y, or if it's all in terms of a single variable, then I always want your answer in standard form. When we get like this, it gets a little tricky. How do we know what standard form is? Well, generally we pick one of the variables and we start with the highest exponent for it and work its way down. But then we get some things like this degree is 6. This degree is 6. This degree is 7. Do I start with the x or do I start with the y? Because y is bigger here, and this has the highest degree. So it gets really confusing. So standard form for us is when it's all in terms of one variable. When we have multiple variables, we're not concerned with what comes first. Okay? All right. So your homework is the 2 workbook pages. So 77 all and 89 just 1 through 4. And then finish up the notes page where you were classifying the polynomials. Okay? This is quick and easy and a great way to start. Any questions? Okay,